Hi guys, I've been asked by a few people to do a platformer game, and today we're going to do a very basic platformer. Create a package for today's tutorial, which is tutorial 14, and then we're going to have two files, main and level data. Level data is just this, so it will contain an array of strings, and each string within the array will represent a row within the game, so row of level. 0 is nothing, and 1 is going to be our platform. As you can see, there is nothing else, so we may implement enemies, coins, and power-ups in some other tutorial. This is our main. As always, extend the application. You may want to copy all those imports right now, not to bother with them at a later stage. So what we have is our main, which just launches the JavaFX application, and I'll go line by line. So this is our map, hash map, which maps a key code to a boolean, and this boolean is basically true or false, which will say if the key is currently pressed or not. And key code is the JavaFX input. Basically, it is an enumeration that will map physical keys to a key within Java, so we can map it in our game. This is the list of platforms. It is useful to store different types of entities within the game in different lists, so you can iterate over them sort of directly. Then we're going to have 3 roots as opposed to having 1 root in previous tutorials. So this is the root. It will be the application root, which will contain other roots and nodes. This is game root, so everything to do with the game entities, platforms, player, coins, power-ups, and all of that will go into this thing. We separate game root and UI root because you want game root to be scrollable, and UI root always sort of stays in the same coordinate space and doesn't move. And separating them into 2 groups or 2 panes is a very sort of neat way of doing this. You can also use camera if you want and have subscenes, but I think that would be easier. Then we have a reference to our player. Every entity within this basic platform will be represented as a node, or as a node. So if you're doing an actual game, then you only want to have a class called entity, which extends node or extends parent, so you can have advanced graphics and things like that. I'm going to have player velocity. We won't really use the x value. It's just a good way of having sort of storing velocity of the player as a vector. Point2D can be a vector in JavaFX. So you can have all operations on vectors are supported for Point2D. CanJump is basically a boolean saying whether currently the player is able to jump. And the last variable, the last field, is level width in pixels. So the first thing we're going to do, let's do start. So in start method, we initialize content, which is this method. We create a scene with the application root. And then we add callbacks to the scene. On key pressed, this is the lambda. So we get code from the event. So this will basically say what key was pressed on the keyboard. Then we put that into our map of keys and then set the value of that key to true. So it will allow us to track whether currently a particular key is pressed or not. And set and key released is essentially reverse of what we did for key pressed. So with key released, we simply set it to false. Primary stage is the main stage that we have. So set title tutorial 14 platformer, or whatever you want this title to be. Set scene, and finally show it. And this is going to be our animation timer, which is a very neat way of having 60 frames per second, or rather a loop that will be called 60 times a second. And instead of writing code within this, we simply forward this, or the terminology is delegate it to another method, which is here update. So this update will be called every or 60 times a second. Now if we go to init content, now let's do that. So it's just this. We create a rectangle which is going to be background, width and height of the rectangle, which will in turn be the width and height of our application. We obtain the level width from level data, so it is this. We get 0th element, which will return this row, so the very first row, and we get the length of it, which will return number of characters within this string, and we'll multiply it by 60. I chose 60 as a block size, so everything in the game will be of 60 pixels wide and high, except for the player. I want the player to be 40 pixels wide and high. So this is basically our parsing loop. This will go through each element within the level data and parse it to transform it to something that will be displayed in our game. We obtain string line, which will be rows. So this is basically a row. We'll go from 0 till the length of this array, and we obtain each row one by one. Then we go through the characters within that row, which is like this, so 0, 0, 0, 0. We get the character that we want, and then we parse it. If it is 0, then we don't do anything, so it's nothing. If it's 1, we create an entity which will be placed at x and y positions, so x and y coordinate. This is the width of our entity, and this is where we define our create entity method. So x, y, width, height, and color. So our platforms are going to be of brown color. And finally we add the platform to the list of platforms, and we break. So they're just zeros and ones, and we don't have anything else. If we had something like enemies, then you'd do another case, define a character for that type of enemy, or type of entity rather, and then create a new entity, perhaps with a different color. We then create our player. We'll put him x0 and y600. He'll be a square with size 40 and blue color. Okay, that we will need for the moving, so basically the scrolling part. We first obtain the property for translate x. Translate x is basically the x position, the x coordinate of that entity or of that node. In our case it's player. And because it's a property, we can add listeners to that. So whenever the property changes, we can have it call this method, or this chunk of code will be called whenever the x property has changed. This is the old value, this is the new value. We only care about the new value, so we're going to obtain an integer value of a new value, which is the offset from the left side of the screen, so basically offset from 0. And it is also the value, the x-coordinate of the player. So if that x-coordinate or offset is greater than 640, so it is basically center of the screen, and it is less than level width minus 640, so that part, we set layout of the game root, so this will affect all of the elements within the game root, and that will be enemies, platforms, player, and so on. To offset minus 640, which will give us the distance between player and the left side of the level, and we simply alter it. So we push the game root to the left while the player moves to the right, and the opposite as well. Finally, we add everything to our application root so that we can see something on the screen. We add background first, then we add the game root, and then UI root in this particular order, because we want UI to be over the game and the game objects over the background. We won't do any UI stuff in this tutorial, but it's nice to have the root so that we can add stuff to it. Alright, so we'll do update. Update is basically all the game logic that we'll ever need. So all the stuff will be in this update method. And for now we only have input processing and gravity. This is the method to check whether currently the key is pressed or not. So if we open this, it simply gets the key code from the map that we defined, and if it wasn't found there, which means that we have never pressed that key during our game, so it will return false by default. And if it does exist within the map, then it will return the value of that key, or rather the Boolean value that is mapped to our key. So if W is pressed and get translate Y of player is greater than equal to 5, so 5 is basically the instant speed of our player, then we can jump. And yeah, so W is going to be jump. You can replace that with space. And jump player, we'll cover this slightly later. So if A is pressed and get translate X is greater than 5 or equal to 5, then move player X minus 5, so basically to the left, and this is basically right. And then we apply gravity. If the player get player velocity get Y is less than 10, so I use 10 as the maximum value for gravity. Then we set a new vector to player velocity and add 1. So 1 is basically acceleration in the y-axis. Then we move player Y by the Y value of the player velocity. So basically Y coordinate is controlled by the application, whereas X coordinate you control yourself. So now if we cover jump player is very simple. If the player can jump, so player velocity at minus 30, remember that Y axis goes down in JavaFX screen, and minus will set it to the so basically minus is the opposite. We jump the player. and we set can jump false so we don't have double jumping. And move player X is so we obtain the value by which we want it to move, and this is where some of the collision detection happens as well, because we don't want our player to be able to move through the platform. So we set Boolean moving right to values greater than 0. So if it is greater than 0, then this Boolean will be set to true, otherwise to false. And we do a loop. Instead of moving the player by this amount of units directly, we move 1 unit at a time this amount of times. So essentially we'll get the same coordinate, the same ending coordinate, but moving it by 1 unit only allows us sort of to do collision detection between platforms, so we don't go through the platform. So this amount of time, remember that this could be negative, so instead of getting the value, we're obtaining the absolute value, which will return positive value. Then for all platforms, we get the bounds for our player, then we get bounds for our platform, and if they intersect, then we have a collision. Now we need to check whether a particular side of a player is colliding. So if moving right, we need to check whether the right side of the player is colliding with the platform, which means that we won't be able to move right. So player get translate x, which is a position of the player, plus 40, it's his width, equals to platform get translate x. We use integers everywhere, so this, and we also move by 1 unit only, so we can do precise collision detection or precise checking. Equals to platform get translate x, then simply return because we cannot move. We hit the platform to the right. Else, which means that player is moving left. We do the same in the sort of reverse order. So we can translate x, which is the left side of the player, and if it equals to platform, get translate x plus 60. 60 is the width of our platform, or width of the block in the game. And we return from the method because we can no longer move. If nothing happened, so if we're still in the method, then we translate x of player to get x plus, if moving right, then by 1 unit. If not moving right, then by minus 1 unit. Exactly the same for move player y. So moving down, and all of that is pretty much copy paste from the move player x, except we're moving in the y direction. And the thing to notice is the only difference is here. So when we hit the platform, so when the player's sort of maximum y, which is bottom side of the player rectangle, hits the platform, we slightly move it by 1 unit to the top, because we don't want the player to be constantly colliding with the platform, otherwise we won't be able to move him at all. And we set can jump to true because we found that the player is on the ground or on the platform, and we return from the method. The rest is exactly the same. And the final method that we have is create entity. So our entity returns node, so you can return an image view if you want it. So you could replace all of the entities with graphics or sprites, and it'll still work. So rectangle, we create a rectangle. Everything in the game is a rectangle. W and H is width and height. We translate X and Y of the entity. We set color, the one we passed, and finally we add an entity to the game root. or to the children of the game root, and we return that entity. So yeah, this is it. And if we run the game, we will see that it parses it exactly as it is in the level file or the level array. So we can use W, A, and D to sort of move, and we can also jump. And the collision system that we did seems to be working. It's not perfect, it is very quickly done. So I'm assuming there will be cases where this collision detection will break. But for the basic tutorial, it should be fine. Yeah, there is no clipping, as you can see, so it's still, you can walk along the platforms. And the screen also follows the camera, the camera that doesn't even exist. So we simply set the layout X to follow, yeah, right here. We set the layout X of the game root to follow the player if the player's offset is greater than 640. So here, this is the level beginning. The X translate X of the player is less than 640, and when it reaches the center of the screen, it is greater than 640, and this kicks in. So you have this sort of an illusion that you have a camera that follows the player. And yeah, that is it for this tutorial. I hope you enjoyed it, and thank you for watching.